Thank you for joining me. Today we're going to talk about factoring polynomials, and we're going to do this in a number of steps. I've actually got 7 steps. The last one will be the summing up. But we're going to start with step 1, the GCF. GCF stands for the greatest common factor, and the first step to factoring polynomials is just to figure out what they have in common, what factors they have in common. So this isn't a factoring problem here, x times the quantity a plus b plus c, but you can see that this is a situation where you would have to use the distributive property. You would multiply each term by x, and you would get ax plus bx plus c. Okay, that's a multiplication problem. Factoring is taking that process and going backwards, saying, okay, I started with ax plus bx plus c, oops, x, I forgot the x. Oh, off to a bad start. Ax plus bx plus cx, and I asked the question, what was multiplied to get this? And you can see that they all have an x in common, so it must be that they were all multiplied by x, so x is the common factor. We take that out, and then what's left is a plus b plus c as our trinomial here. Now, let's do that with some real problems. Factoring out the greatest common factor. For this problem, we have 3x cubed plus 5x squared minus 7x, and we can clearly see that they all have an x in common. There's x cubed, x squared, and then just x to the first power. So there's at least one x in each term. We also notice that the 3 and the 5 and the negative 7 have nothing else in common. Right? There's nothing times something times something that equals 3, and the same something times something equals 5 and 7. There's no common factors there. So we can just take out, just like we did before, we can take out the x. So we can say, okay, there must have been an x multiplied by each of these. And then we have to ask the question, and how you ask this, I'm going to do several different ways of thinking about asking this question. But we have to ask the question, if I multiplied something times x and got 3x cubed, what was the something I multiplied by? Or what is 3x cubed divided by x? If I divide out an x, what's left? And hopefully you can answer that question by saying 3x squared, because x times x squared is x cubed. And then I have to ask the same question of the next term. I'm going to keep the sign, plus, and then 5x squared, what happened? What did I multiply by to get 5 by x to get 5x squared? And of course the answer is 5x to the first power, because x times x is x squared. And then I'll keep the sign, negative sign, and I'll ask the question again. What did I multiply 7x by to get, or what did I multiply by x to get 7x? And of course the 7x is 7 times x, so it must have multiplied 7. Or you can think of it as negative 7. All right, and there it is. We factored out the common factor. We identified it, and we were able to identify it visually, and then we took out that one factor from each term, put it out front in outside parentheses, and then whatever was left over is left behind as our other factor. So the factors here are x and 3x squared plus 5x minus 7. And it is indeed true that if you were to multiply x times 3x squared plus 5x minus 7, you would get back to the original problem. And it's always helpful to try that out before when you're first beginning this. But keep in mind that that's just the check, and the answer is this. These are the factors. Okay, let's try that again. Let's do that with 15x squared plus 25x minus 35. Now, once again, I think you can probably tell what the common factor is, or at least a common factor. Because you can see that even though there's not an x in each term, x squared, x to the first power, and then the 35 doesn't have an x at all, that each of the numbers ends in 5, and so it can be divided by 5. So we're going to say, without really even trying this, at least to start, we're going to just say, well, I bet you the common factor is 5. Okay? And for easy problems, you can do this. You just kind of visually look and say, I think this is the answer. And so we say, well, if we took out a 5 there, or what times 5 equals 15, and we would say 3. And so we say, well, then it must have been 3x squared. That got me the 15x squared there. 5 times 3x squared is 15x squared. And then for the second one, I say, well, what times 5 is 25? Oh, it's 5. And 5x. So positive 5x. And then for the third one, I say, well, what times 5 is 35? And it's 7. So it would be minus 7. And once again, we can see that if we multiply 5 times 3x squared plus 5x minus 7, we would get 15x squared plus 25x minus 35. And so this works. So the greatest common factor can be a variable, or it could even be more than one variable. It could be a number, a factor of each coefficient, or it could be a combination of the two. And if the problems are simple, like these ones, it's often easy to find what those are. But what if the numbers are not simple? And this is the real method. This is what I want you to kind of to latch onto, because this always works. And there's two ways to do this. Let me go back to this last problem and just kind of show you how I would have done this on the last problem. On the last problem, I would have just written out each term in factored form. So I might have even written the negative 1 there. Okay, so then 15x squared is 5 times 3 times x times x. 25x is 5 times 5 times x. And then negative 35 is negative 1 times 5 times 7. And then once I have it all pulled apart like this, I can circle the factor or factors that are the same in each term. It's really easy to see because they're all pulled apart and they're all factored out. We're going to do the same process here with the 30x squared y plus 45xy minus 90xy squared. But I'm going to do it because I think I'm not going to have room to just write the little versions of each factor underneath, the prime factors underneath. I'm going to actually write them out like this. I'm going to write, okay, 30x squared y, that would be, well, let's see, 30 is 2 times something, right? 2 times 15, which is 3 times 5. 2 times 3 times 5. And then x squared is x times y. Or x squared is x times x, and then there's a y. Okay, so I have the prime factorization of that first term. And now I'm going to do the second term underneath it, 45xy. Well, I know it's 5 times something, right? 5 times 9, which is 3 times 3. So I've got the prime factorization there. However I think about what's 45, I do the prime factorization, and then there's an x, and then there's a y. Okay, now I'll do the negative 90. Negative 90 xy squared. That's negative 1. And then 90, let's see, well, it's definitely even, so there's a 2 there. And then there's a 9, that's 3 times 3, and then it's times 5. So however you think about that, and if you have to do a factor tree off to the side like this, 2 times 45, which is 9 times 5, which is 3 times 3, and then the prime factors are 2 and 3 and 3 and 5. However you get the prime factors is fine. You can kind of puzzle those out any way you want to, but you need to have a very concrete and complete list of all the prime factors in one place. And then you can compare all the prime factors for each term of our polynomial together. So 30x squared y, 45xy, negative 90xy squared. I have all their prime factors listed, and then I could notice, oh look, the first one has a 3, the second one has a 3, and the third one has a 3. They all have a 3 in common. The first one has a 2, the second one does not have a 2, and the third one does have a 2, so the 2 is not common to all three. It's common to the first and the last one, but it's not common to the middle one, so I can't pick that as one of my common factors. But the first one has a 5, and the second one has a 5, and the third one has a 5. So 5 is part of the greatest common factor. It is a common factor. Notice that each term had at least one x in it, and then each term had at least one y in it. So now that we've gone to all that trouble, let's write out our answer, and I'm going to do it down below here. The common factor then is 3, 5, x, and y. The greatest common factor is 3, 5, x, and y, which is 3 times 5 is 15, times x, times y. So that's my GCF. That is the GCF, the greatest common factor. That's what we're doing here. And then, what's left over? Now, if you did this carefully, you can clearly see what's left over because it's going to be here in the factors that are not circled, right? The first term has a 2 and an x in it. 2 times x, which is just 2x. The second term has a 3 left over. That's it, just a 3. So then keep the sign, it's plus 3. The last term has a negative 1, and a 2, and a 3, and a y left over. So there's a lot of factors there still. So that's negative 6y. And there it is, 2x plus 3 minus 6y is my trinomial. And if I multiply that by 15xy, I get, well, 30x squared y plus 45xy minus 90xy squared. So I can see that I took out the greatest common factor. And how do I know that I got it right? Because when I took my terms and factored them completely, it's very easy to see all the common factors. If I just go for the quick and easy one, let's say that I looked at this and said, oh, I can tell for sure they all have an x and a y and a 3 in common. Right? 3xy. Really easy to do that. If I had done that, then I would have been correct to say that it's 10x plus, let's see, if I take out the 3 there, what is that, 15 minus 30y. That would have been correct, but that's not the GCF. It's not the GCF, and so we say it's not factored completely. And you can tell because you look and you see that each of the terms, the remaining terms, have a factor of 5 in them that I didn't catch. So that's always possible that you didn't catch the GCF if you don't, if you kind of do that first method of just kind of visually looking and seeing what you can identify. So watch for that, but good news is that this isn't wrong, it's just not finished, and I just need to go back and take out a factor of 5 and put that 5 into my common factor and finish off the job. Okay, this is called factoring using the greatest common factor. It is an important first step for all factoring. Later on, we'll get factoring problems where we don't have common factors, but this is the first step. It's always going to be the first step. Is going to be the most important. It's also the easiest step. So you always want to do this because it makes your polynomials simpler and easier to deal with, and easier to look at, and easier to factor further if you can take out the greatest common factor. So thank you very much for watching, and I hope you watch the rest of the recordings.